Mic check. Okay, whoops. I forgot to turn my microphone on. My bad. Evening, guys. How's it going? Hope you're all well. How's your evenings going? We're going to start this little live stream off with a little bench test of an amplifier which I repaired previously on another live stream. This is a baby little MTX Road Thunder RT501. We're going to bench test it and see whether it makes the 500 watts that it claims to make. So, let's just do this real quick. I wonder how much power we're going to see. What do you reckon? 500 watts? This is a Class AB 500 watt RMS mono amplifier. Will we see 500 watts, I wonder? What's going on the microphone? Mic check. Okay, yeah, the microphone was playing up a little bit then. I've just changed the setting on the microphones. Hopefully that sorted it. Does the sound still sound alright to you guys? Right, cool. Let's see then. Let's see how much power she does. So here we go. There we go. So that's like 0.5% THD. I've gone under the clip point there, just where the clip point starts to show. So let's see. How many watts was that? 220. Now we're gonna get more than 220. Okay, so that was 27.88 volts, and that was at 2 ohms. Now this is at 12 volts, so we have to recalculate it for 14.4 volts. So that was 388 watts at 12 volts. So if we calculate that for 14.4 divided by, so we use the correction factor, which is 1.44, so 388.64 times by 1.44 equals, oh, someone got very, very close, 559.64 at 2 ohms. So there we go, fantastic stuff. Little MTX Road Thunder, that's just a little bit overrated, and that was beautifully clean as well. That was like a super duper clean sine wave. Yeah, that would be like 1%, probably 1% THD that was. If I pushed it into a little bit of soft clip, we probably would have seen around 600 watts. So very nice, not bad at all from this little thing. And it will sound lovely as well because it's a Class AB, so it should have a wonderful, effortless, nice sound to it. Okay, how's it going in the live chat? RIP headphone users. Ah, is that the fans? Yeah, the fans are a bit crazy. Do you have an Amazon wish list that fan could buy you a little something? Ah, Dave, very kind of you to suggest that. I don't have an Amazon wish list, no. Generally, if I want something on Amazon, usually from Amazon it's pretty small stuff, so I just buy it. No. I don't have an Amazon wish list, no. But I appreciate the thought there. Very nice of you. Yeah, Sniper King was very close with 570. Some older MTX amps was way underrated. Yeah, this one pretty much is a teeny bit underrated. Makes pretty much bang on rated power. Pretty nice, not bad at all. Somebody suggested that I should get an amp dyno, like Steve Mead has and all the other guys. Do you know? Does anyone know? I know how much the amp dynos cost. Is anybody aware of actually how expensive the amp dynos are? It's fucking ridiculously expensive. It's pointless me getting an amp dyno for what I do in here. There's no point. It would not benefit me, really, in my business. It would not benefit me at all. So, little baby MTX Road Thunder can go back in its box for another day. It actually came in an SPL Dynamics 1500 box, so that can go back to the customer now. Very nice, very nice. Yeah, the what do you call it? The amp dyno is actually £2,000 in the UK over here. Okay, so we are going to continue looking at this Rockford Fosgate. So this is a very, very nice amplifier. This is a Rockford Fosgate. This is the BD1500.1, and it's one of the annoying ones that has all the FETs soldered to one of these heat spreader bars here. So if you want to change the FETs, you have to desolder the actual FET itself, the back of the FET from the bar. Fortunately for me, none of the FETs are actually damaged. I've just removed this from the board because I wanted to make some tests. I wanted to read some voltages without the FETs in the board because I did not want to kill any of them. Because if I killed any of them, then I've got to desolder them, and that is going to be not the funnest thing that I've ever done. So I decided to go ahead and just take this off the board, desolder all the legs of the FETs to take this off the board, so I could then do some tests with them out first. Now, when we looked at this amplifier, oops, there's stuff. Oh yeah, I forgot I put stuff on the board. Anything else? No. When we looked at this amplifier before, it wasn't doing anything, it wasn't coming on at all, and some part on here, some op amp was reaching something like 160 degrees, so that was no good. So put this FET away. So I've changed a couple of parts. So off camera, off stream, I changed a couple of parts on this. So this amplifier, we actually do have a schematic for this amplifier, but I haven't really used it yet. I've just been changing parts to get super duper hot. So if we take a look at this board here, you can see that we have a large chip here that does most of the controlling of the amplifier. We have a few op amps here, like here. The driver ICs are actually here. Now the driver ICs look like small little transistors or FETs, but they're not. These drivers are they have 5 legs, and these are actually an IC, but they're in a TO220 package. So that's an IC, not a FET or transistor. It's like a IC like this, but just in this case. So these are the drivers. So now, because this amplifier can be could potentially be a little bit of a headache in terms of, troubleshooting and spending lots of time with it, I thought the first thing that I would do with this amplifier is actually block replace a bunch of stuff. So that means just blindly replacing the most immediate things that drive the outputs, in an attempt to very quickly make a repair and hit the jackpot on whichever part was causing the issues. Now it looks like these have been damaged by vibration. We've got some very weak legs there. So these were the original drivers. So I'll put those to one side. I've ordered 2 fresh driver ICs here with the 5 legs. It looks weird, doesn't it, with the 5 legs? So let's get these out. I'm going to put these in a moment. Oh yes, but I actually got one side of this amplifier working. So off of live stream, so I forgot to mention, I replaced one of the LM6171 ICs, and I replaced a TL072, and actually half of the output section started working. So I know that I'm on the right track here by replacing these parts. So what I decided to do was just go ahead and order a whole bunch. I ordered 2 new drivers, and I ordered a bunch of replacement TL6171s. So I'm going to go ahead, and these are pretty cheap. This is not expensive stuff. So I'm going to go ahead and block replace the remaining TL6171. So we replaced this one before. So I've got 1 to replace here, 1 to replace here, and 1 to replace here. So let's go ahead and do that first. I don't do a great deal of this block replacing stuff, but where these amplifiers can be a bit of a headache, I just wanted to see whether I could order some parts for pretty cheap and not spend much time on this, because I've got a lot of stuff to do. So if I can spend a minimum amount of time on an amplifier, then that works out good for me. So let's get 3 of those. The other ones here, these appear to be voltage regulators. So I checked the voltages on them, and they actually don't seem to be bad. They seem to be just fine. So I don't think we need to replace those. So if I go ahead and remember which ones I need to desolder, so it is this one, and where are we? This one. Okay, so yeah. Good evening, produced by Zenith. How's it going, buddy? How's it going, yo? I'm curious as to what Basehead 30's message was. Whenever somebody retracts a message, I'm always like, wonder what they said. I would have quite liked to use my desoldering gun for this, but my desoldering gun is actually completely clogged up with solder because it absolutely is rubbish. It's the worst desoldering gun in the history of desoldering guns, so it's super clogged up. Evening, John Paul. How's it going, buddy? I might even get round to John Paul's amplifier at some point over the next couple of days on the live stream. Because I have had a bit of success today and the last couple of days. So my workload, yeah, is slowly whittling down. So I usually tend to quote for a longer repair time than perhaps it would actually take, just in case there's any unexpected problems, or like I need a part that isn't available. So rather than saying to the customer, oh yeah, it'll be done in a week's time, and then I have to order a part that's like on a 2-week lead time, it's better just to say from the start, you know, it could take a little longer, but I'll keep you updated. And that way, if the repair's done sooner than the customer expects, then it's a good thing. But if there are any issues, then obviously you've got a bit of headroom and a bit of time for whatever the issue is to resolve itself. Jesus. Someone's texting my phone like crazy. We will speak to them guys later. Okay, that's one IC. So put this down to the side. And the other one was up here, over at this one here. Let's go ahead and change that one off. I really don't mind using the manual solder sucker. It works really quite well for me, I find. I've got used to using it now. It'd be really interesting to see how much the Hakko makes a difference. Well, it'll stop that from happening, that's for sure. I hate it when that happens. You finish sucking something and it dumps a massive chunk of the solder back on the board. That's very annoying. So the Hakko won't do that, that's for sure. How do I keep the thread part of a solder tip from seizing up? I have no idea because I've never really used a threaded soldering tip. That sounds like it would be a nightmare. Yeah, for sure. The soldering tips I use just literally slide in, and they're interchangeable. They're very quickly interchangeable, so that's very handy. So we've got 1, 2. That's 2 out the board, and the third one is all the way over here. I think it's this one that looks like it may have been removed before, because there's some solder flux on there, so interesting. Jimmy says I've repaired over, well, a lot. Over 300 of those Rockfords. I can show you an easier way. Cool. So Jimmy looks like it might be a very useful, a very handy guy to have on the live stream. If you've repaired so many of these, this is actually the first one that I've had in the workshop. There's not a huge number of these floating around the UK. So yeah, there's not a great deal of them to gain experience from over here. So if I run into any issues, perhaps Jimmy will be able to point us in the right direction to get this thing up and running again. I am quite confident though that just block replacing these components will resolve the issue. I hope so. I like it. Generally, when I'm confident about something, you know, you have a positive mental attitude, and things generally tend to go your way if you have a good feeling. There we go. That's our 3 ICs pulled, and no pulled vias either, which is good. So I'm going to go ahead and drop the new ones in. LM6171. Beverage, what did you use to clean off the flux? I use acetone and ended fucked up the brush. I use I just use 99% isopropyl alcohol to clean off flux and stuff from the board. I actually sell those 5-leg drivers at eBay. Oh, interesting. That's pretty cool. We talked before. Awesome. That's cool. Okay, solder these bad boys in, and then I'm going to read the drive waves on the pads for the driver ICs before I put them in to make sure that they're not getting anything crazy funky that might blow them. And get these finished. Just going to bend the legs out so that they stay in there and don't fall out when I go upside down. Yeah, 70% alcohol doesn't work either. I accidentally purchased some 70% alcohol, and it's absolutely rubbish. And also, the 70% alcohol is conductive. It conducts electricity, so you can't use anything other than 99% isopropyl alcohol. You might be able to get away with using 90, but I've not had good success with anything other than the 99% isopropyl alcohol. Yeah, the 70% stuff is conductive and it doesn't clean shit. The 70% stuff seems to be for your body. So on the bottle of 70% isopropyl alcohol, it says like you can rub it on your body and it does something. I don't know, wounds maybe? No idea. The flux I use does not need cleaning. Yeah, I actually use some of this flux, and this doesn't need cleaning either. This is pretty cool stuff. This is like alcohol. It doesn't need cleaning. But the flux that other technicians leave on the board, generally it's a good idea to clean that off. Okay, cool. Right, that's stage 1 done. So I wanted to replace all those ICs, just block replace those ICs first. Now what I'm going to do is I'm going to power it up, and I'm going to see what gets hot on the board, because some things were getting a little bit hot before, and I'm then going to check the drive waves on the pads for the drive ICs, and we may need to pull up the data sheet for the drive IC as well, so we can just make sure that the correct voltage is going to where it should be. Just tuning in from Australia, loving the streams. Holy crap! Hi from the other side of the world. It's crazy, that, isn't it? It's so crazy that you can watch me in the workshop from flipping God knows where, miles away. Oh, that one's positive. Also, with these Rockford BD amps, the caps store a lot of energy. Yeah, trust me, I'm fully aware. Yeah, they store a lot of voltage, and they don't discharge. They don't seem to discharge. There's no pull down resistors on the main rails, so you have to discharge the amplifier every time you turn it off. Okay, and the remote wire is a little bit annoying on this amp. I'm actually going to have to solder the remote wire on because it doesn't stay on otherwise. The remote on these amps is on like a little spade terminal, so I have to solder the remote wire on here. Go, just solder the remote cable. Right, let's give some power and see whether we have sexy drive waves where we should. Let's get my scope on the right settings. Now, I'm gonna pull up, before I go any further, I'm gonna pull up the spec sheet for this. So this is MIC 4420 ZT. And I should have a PDF for this. Here we go. I can get a pin out. Okay. So, 1 is in, 2 is ground, 3 is VS, which is supply input. Duplicate pins must be... Okay, so that's the supply input. So ground and ground is the same, and then we have the output on pin 5. So in, voltage, and out. Voltage, supply, and out. Simple. Okay. So these, if I'm not mistaken, go in this way round on the board. If I come back to my camera here. Do you have any experience with Hyphonics Triton series? Not the Triton series, no. I've had a lot of experience with the Hyphonics Brutus and the Zeus and other stuff like that. All the Hyphonics stuff I get in is really generic stuff. It's not great build quality, pretty generic amplifier boards, okay parts used, and they never made rated power. All the Hyphonics amplifiers I've ever prepared have never made rated power, so I don't really rate Hyphonics that much. Anyway, so yeah, these go on the board like this way round. So pin 1 is going to be here. So pin 1 is in, so pin 1 should have the wave on it. So let's turn our power supply on, and let's see what the jam is. Let's turn that on so you can see my supply. Okay, I'm going to allow about 3 amps to pass. That should allow us to charge the rail caps up quickly enough, but not allow any damage to occur if there's a problem. I'm just going to grab my thermal imager as well, because on this board, when something's not right, it tends to get super hot super quick. So I don't want to damage any of those new parts I just fitted. So let's put our oscilloscope probe on pin 1 here, and I'm just going to go ahead and turn her on and see if anything is heating up here. Okay, let's see. So it's drawing 1.7 amps. On the scope we've got something small. Actually on the scope we've just got a little bit of noise. On the scope there's some noise from the power supply, so that's nothing really, that's nothing interesting. Okay, something is getting hot on the board. Let's see what that is. How hot is it getting? So we've got the main IC, which is reaching 26 degrees. That's very normal. A couple of the op amps over here are reaching like 27. That's fine. Over here, we've got a pull-down resistor, which is reaching 36. That's normal. And yeah, so the new ICs that I just fitted seem to be staying pretty cool. So that's nice. Now I might need to feed this amplifier with some RCA signal to get a square wave on the inputs of those drivers. So I'm going to go ahead and take my signal generator here and plug something in to the RCAs. I can't remember which one is input actually. That's annoying. Which one is input? From memory, it didn't matter. I don't think it mattered which one was input. So I'm just going to go ahead and pop that in there. Turn it down a little bit. Okay, let's turn it on again. Okay, it comes on straight away this time because we're not charging any capacitors. Okay, doesn't seem to be any drive waves on there, or there either. 1, 2, 3, 4, 5. Okay. Ah, yes, there is. Wait. I'm pretty sure that's just noise from the power supply. If I remove my RCAs, does that go away? No. I think that's just noise from the power supply section. Because that's only 1 volt worth of noise. Okay. Measure temperature in Celsius. Yeah, of course. Celsius. Okay, so I think I can put my thermal imager away because I know nothing is getting hot on the board over here really. So I'm actually just going to Google up a picture because I'm not sure where I put the end plates for this. I want to make sure all the switches and stuff are in the right position to accept an input. So Rockford BD1500. I'm just going to quickly Google a picture of this. I think this is her, isn't it? Yeah. Okay. So if I go ahead and look at the picture. The model of this thermal imaging camera is a K-Moon. It's some piece of crap. It's actually, I wouldn't recommend this. I actually want to get a FLIR. This is some piece of crap thermal imaging thing, I have to say. Why is this not loading? Right, here we go. That's what I wanted to see. So the input is actually closest to this knob here. Okay. Looks like we've got gain, which is next to that. Phase, which is next to that. Subsonic filter, which is next to that. And then I think that's probably the filter frequency next to that. So that's pretty simple. That's nothing too extreme. I'm having some beer while watching. Ah, cool. Jimmy, have you ever measured the drive waves with the drive ICs out of the board? What are you supposed to see? Are you supposed to see? I would have imagined I was going to see the drive wave at the frequency that I'm inputting to the board. Ah, here we go. Now we got something. Looks like the gain's actually a little high on here. We've got a bit of a square wave going on. I don't think I can get rid of that. There we go. That looks better. Okay. So I can flip the switch. So we've got a nice looking sine wave there. That's going to be the input to one of these op amps, which is going to be responsible for part of the drive. So I don't think this op amp is outputting what it's meant to output. This is the original one that I replaced, so I wonder whether it died again. Ah, wow. Okay. So, we have some drive there. That looks promising. It doesn't seem to be getting to the drive IC, though. Oh, maybe it is. Hang on, there we go. We've got something on pin 5. So we've got something on pin 5 of the second drive IC. That could be a low side drive, which could then oscillate the high side drive one over this side. So okay, that could be working. It's very hard to tell because I've never repaired one of these before, so I don't know what it's meant to do. If that makes sense. So I'm actually going to go ahead and discharge the rail caps first, and that's why when you did the Orion, I saw your excellent in techniques. I know how to repair these, but not technical. Ah, okay, interesting. All right. So, Jimmy, what's your normal repair procedure on these then? So I think we've got some sort of drive waves on pin 5, which is the output, interestingly enough, of the drive IC. Very curious. We've got an op amp here which has got the Class D switch wave. We saw a Class D switch wave definitely on this op amp. That was a very Class D looking square wave. I'm going to check the other side. I didn't check the other side. Let's check the other side and see what's going on the other side. So we had a very Class D looking square wave on this pin here. That's a very Class D looking square wave, and that is at 44 Hertz that I'm currently playing. So something is working fine there. Let's go over to the other side. And what do I have going on over this side? Ah, look, I have the square waves on this side as well. So the LM6171s are doing their job by the looks of things, and the waves are getting to those. I would have thought that we would see that wave on pin 1 of the drive ICs though. So it's curious that we don't get anything on pin 1 of the drive ICs. Huh, look at this. Ah, look, we've got a triangle we're meant to. I don't know, I wonder if we're meant to have we've got a triangle wave, which is obviously the triangle wave is used to generate the Class D switching square wave referenced from the sine wave. That's on pin number 3. That's on pin number 3 of the LM. So pin number 3 of the LM over this side doesn't have anything on it. It just has some kind of squiggly dots. See that? So there's nothing on pin 3 of the LM over this side. That's annoying. I wonder if there's meant to be or not. I can maybe trace it back and see whether there's meant to be a triangle wave on there. Perhaps not. We've got our sine wave on there. Definitely clipping the shit out of it though. I can't actually turn my my frequency generator. I can't turn the volume down any lower. It's as low as it goes. Okay. So what I think we're going to do then is, because I can see some drive waves on the amplifier somewhere, I know that part of the drive circuit is working. So I'm going to go ahead and discharge the rail caps, and then we're going to plug the drive ICs in and see what they do. So let's flip this thing over. Be very careful because there's a lot of energy stored in these capacitors. So we've got to flip her over. Take our discharge resistors, which are also my dummy loads I use for amplifier bench testing. I'm going to put these in series to give an 8 ohm load. 8 ohm is quite low for discharging these, but I want it done quickly. I ain't got no time to be waiting around for like minutes whilst it discharges. So we're going to get a nice little spark and it will discharge. Ah, no spark. Interesting. Usually we get a spark. Cool. And we can just double check that that discharged by measuring the voltage on here. The voltage will be on the rectifiers. The rectifiers are not the 3205s. I think they are these bad boys over here. Yeah, I think that discharged. Yeah, there's no voltage here anywhere. So, okay, cool. Just gonna make sure there's no voltage waiting on the driver ICs when I touch my soldering iron. No, looks good. Cool. So let's drop the drive IC in and see what happens. Hi, Brian. Now the drive ICs, I need to bend the legs in a very specific way to get these to go in. So I need to mimic what they've done here already. So this is the original drive IC. You can see the legs are bent in a certain way. This camera is way too overexposed. Let's see whether I can fix that. I think this might have a filter on it. Turn the gamma down a bit. Starting to look a bit better. Contrast maybe. I think that might look a bit better. Yeah. I'd say that probably looks a bit better. So yeah, anyway, the legs are bent in this kind of fashion here. So we've got to just take our pliers and bend them in a roughly similar fashion so that they go in. doesn't have to be exact, just kind of roughly so that they go into the same place. I do have a schematic for this Rockford, yeah. I'm not going to lie though, because I didn't go to electronic school or anything like that, I'm not the best at reading schematics, so the schematics aren't a huge help to me. The schematics only are helpful if I'm like struggling to find what a part is or what a part connects to. If the schematic told me, so if the schematic had on it where the drive waves should be and what voltages they should be at, then that would be a useful schematic. But they never do. Schematics just tell you what parts go where and what everything's connected to. So because I didn't go to electronic school, that's not massively helpful to me, because I do struggle to read schematics a little bit at this point. I've only been doing amplifier repair for 1 year, so yeah, I've just been doing it from, I've just been basically repairing amps and learning from repairing amps, rather than all the technical schematics and stuff, and yeah. All the background info is not my strongest point. Yeah, the legs bent pretty well on that one, so I'm going to do the same to this one. Greetings from Mexico. How's it going, buddy? Correct, sir. Schematics. I do have a lot of schematics. Only valuable when a part is badly blown or I'm unable to see the part number. Yeah, I feel the same. So some people are fantastic with schematics. I'm not the best with them. Schematics aren't hugely useful in finding like where an issue lies. I find a more practical approach is more effective for me. My dad used to draw schematics on car amps. I'm not even half as good in repairs compared to my dad. That's cool. Your dad's probably very experienced, Jimmy. Alright, so that's our that's our two new driver ICs fitted. So I'm going to do the same thing again. No output FETs. I'm just going to plug the RCAs in here. And like I say, I'm not familiar with this circuit, so I don't know what I should be seeing on the gates of these output MOSFETs. But if other Class Ds are anything to go by, I imagine I would want to see some kind of square waves in relation to the frequency that I'm playing on the gates. Okay, so yeah, power time. And I fitted some new parts, so I'm going to turn my thermal imager on again and make sure that fitting my new parts doesn't cause anything to heat up or explode or anything like that. So we were drawing 1.6 amps before on the power supply, so I'm going to see whether we draw still 1.6 amps or excessively more or any less. So now we're drawing 1.9, that's fine, 1.8, so yeah, we're drawing about the same amount of current. That's fine. So now let's put this on some gates and see if anything happens on any gates. Nothing seems to be happening on any gates. Really? Nothing's getting hot, I don't think, so... Got something reaching 35 degrees, but it's an IC. 37, 36... I wonder if there's a small IC here that's overheating a little bit. It's a small surface mount IC. It's reaching 36 degrees, which isn't excessive. It's not excessive, but... So let's keep going then. Aha, here we go. Okay, so I found some waves. So here we go. Here's some drive waves, okay, and these is on the gate of some of these FETs. So the drive that I've found appears to be on the gate of the IRF 3415. Okay, so we've got drive on the IRF 3415. We don't have any drive. Oh wait, yes we do. We have. Oh shit. Okay, awesome. So we have drive on all of one side, but we don't have any drive on the other side. Bugger. I think we should have drive on both sides. So there's something which is preventing the drive from getting to the other side. So it's the same issue that I had before. So I think that this amplifier is working on one side, but the other side's not the same. So the other side should be relatively well mirrored. So we possibly need to work out why the drive isn't getting to the other side. I think that there should be the same drive, because this amplifier is pretty much is a full bridge amplifier. It's a full bridge, so it's basically two channels that are in bridge mode with each other, and so I think the other side of these should also display the drive waves on them. We've got IRF 3415s and IRF 6215s, and on one side they all have drive waves present. On the other side, they don't have anything present on the legs. So, let's go back to our drive ICs. So I'm going to measure pin number 1 of the side that is working, and I'm going to see whether that gives me any drive. So it does. So pin 1 is giving me drive on the drive IC. You can see that there. On the side that doesn't appear to be working, I don't get any drive whatsoever on pin 1. So what I'm going to do is I'm going to trace my way backwards from pin 1 of the drive IC to see what component is next in line that sends the drive waves to the IC. Because if we go backwards from the IC, we might find something that is blown down the line. But before I do that, discharge. Jimmy says the second part have signal but the front do not, I believe. That's curious, because I believe this to be a... I mean, I can fit the FETs back in place and see what happens, but I really do believe that we should have drive waves on both of these sides. There we go, got a little spark that time. Small spark that time, nothing crazy. Teeny little spark. Either way, I'm just going to work my way backwards from that second driver, just because I'm very curious to see if I find anything that's out of tolerance. So we're going to go ahead and look at, this is our second driver that doesn't seem to be doing anything. So if I go look at pin number 1, so if I follow the trace of pin number 1, we can see that it goes and it actually seems to go it actually seems to go to some of these gates. Okay, so it seems that it's using pin, oh no, sorry, whoops, I was looking at this backwards. Pin number 1 is over here. Stupid ass. Yeah, I was looking at it backwards, so sorry, pin 5 is the output, so that's fine. I should I should probably power it up again actually and see. Actually no, there's definitely no waves on pin 1 because there's nothing on the output, so that's okay. So pin number 1, what's connected to pin number 1? We can follow the trace around here. Let's see, what are you connected to? Pin number 1. We've got this is quite a, the traces are very much the same color as the board, so it's not the easiest thing to see. Let's see if I can get a bit more light on this. Shed some light on the situation here. My nice bright bulbs have been blowing, so the light is not great in here. Okay, so it seems that we've got continuity to a resistor here, which is called R124. See that there? I don't know if you can see that. Yeah, I'm going to zoom in a bit more because this is small stuff now. This is small stuff now. That's better. So pin 1 has continuity to a small resistor here. So this small resistor, if I bring it into the light just for a second, should be, it's a 1501, so it should be 1500 ohms. So let's measure her, and is she 1500 ohms? She is 1500 ohms. Okay, that could be some kind of pull-down resistor as well. So we're going to see what else perhaps this this pin 1 is connected to. I'm going to run my probes along some of these op amps just to see whether it's connected to any of these op amps directly. Doesn't seem to be connected to any of these op amps directly. That's fine. It's also connected to R125. And it's a direct connection. So R125 is a little blue resistor, like a little small blue colored resistor here. It could be a fusible resistor. So let's see, if I bring this up to the light, what's that supposed to be? That is supposed to be 3010, so that looks like it should be 301. And there's a mirrored resistor on the other side, so look, if we look on the other side of the board over here, this circuit is mirrored, so we've got the two resistors the same here. So I can measure, I think that should read 301 ohms. So if I go ahead and take my multimeter here, so yeah, we've got on the multimeter basically 301 with test lead resistance. So if I measure it on this side, what do we get over here? Okay, we also get 301, so that seems to be okay. So let's continue following this back. So we've got continuity there on R125, continuity on R124. Where else do we have continuity? Anywhere else around here? We might have to go the other side of R124 because the drive might pass through R124 and then go back to somewhere else. So let's see. I'm going to have a quick look at the good side. The good side will tell me things. So I think that the drive is meant to go through R301 because that is a low value resistor. So that'll be like some kind of pre-gate resistor, like some kind of input resistor to kind of, you know, for the input of the drive. So I'm going to go and shoot over to the other side of the 301 ohm resistor. I'm going to shimmy over to the other side of it, and I'm going to then check for continuity to see what's on the other side of R301. Looks like we have the output of this A2211. So we have, you can see here, I'll bend this forward a little bit, we've got this here, this pin, which is pin 5 of A2211, is connected to this resistor, and this resistor is connected to the input of the driver. So it's very possible that this A2211 is dead. Now, I don't have any spare A2211s, but what I do have is I have one over here that I know works. So what I could do, just to rule out, to see whether that is the actual problem, I could swap the two ICs around. I could put this 2211 over here and put this 2211 over here, and then if this side starts working, which wasn't working before, and this side stops working, then I know that the issue is a bad 2211. So that's what I might do. Secondly, what I could also do is I could measure some diode mode readings on the multimeter across these parts to see whether they have the same readings. So let's go for the good one over here. So the good one that's giving me the drive waves that I need. If we put our positive multimeter probe on pin 5, which is the output of this, and then, I don't know, let's say measure to pin, so pin 1 is nothing, pin 2, pin 3, pin 4. Might have to swap the probes around. I'm just going to compare random diode. Okay, so pin 7. So between pin 5 and pin 7, I should have 559 roughly on the multimeter. So let's compare that to the one over here. Okay, I've got 559, so that's the same. So let's see some other readings. So between 5 and 8, we have 480. And this one we have 419. That's a little bit lower, it's a bit different, which is curious. I'm going to flip my probes round. So now we're going to put the black on pin 5, and I'm going to see some readings on these other pins. So we should have nothing, 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 nothing. We should have about 13 on pin 7 and 13 on pin 8. So 13 on pin 7. So we have nothing on pin 7 of this one and nothing on pin 8 of that one. Interesting. And we should have had nothing, 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 nothing that way round. And the other way around we should have also had nothing, 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 nothing. Nothing, nothing, nada, nada. Okay. Oops, I'm measuring the wrong IC. I was measuring the, aha, okay. So we've got 13 round this way on the one that's bad. On the one that's good, we don't have 13. So it's very possible that this IC is actually dead, because we have quite different diode mode measurements between the two ICs. So what I'm going to do is I'm actually going to pull both of those ICs. I'm going to mark which one is the bad one. I'm going to take my this thing here. I'm just going to put a mark on the edge here, a scratch, so I know that this one's the one that is potentially bad, or was from the bad side. I'm going to remove both of them, and I'm going to compare their readings outside of the board, because the circuit board could be skewing my readings. What have we got going on in the live chat? Yes, the A2211 goes bad most of the time. Oh, cool. Okay. Well, that's probably what the issue is then. So I'm going to remove, like, if I'm going to replace one of them, I might as well replace both of them. I think from RS Components, I think ordering one is about the same price as ordering two. So if I need to replace one of them, I'll replace both of them anyway. So, yeah. If the backside outputs are good, I never seen a Rockford BD driver or regulators goes bad. If you get distortion, most likely U17 is bad. U17, ¿dónde está U17? Where's U17? Ah, U17, yeah, I've replaced U17 already. So I think that one's going to be okay. Much love from the States, says Ken. Thank you very much, buddy. Much love from the UK to you, my friend. Cool. Right. let's remove both of those then, because I'm probably going to go ahead and replace those anyway, because Jimmy says we may need to replace those anyway. So, did I discharge the caps? I think I did. I'll be very happy if I get this working, because having a board that's so alien, like, so when I was first starting with amplifier repair, I had a good friend of mine who also did amp repair, who was guiding me and helping me through with a lot of the repairs, and so I would ask him questions and stuff like that, but I don't tend to ask him much anymore. So when I get an amplifier like this in, that's like a mystery to me and I've never repaired before, it's always a really nice feeling if I manage to repair it without actually having to ask for any assistance. Holy shit, I need to change the coil in that. Ugh, that is grim. Oh, thank you. Now, where were those ICs we're changing? There they are. Okay. This is the first time I ever watching somebody repair an amplifier for so long. What do you mean? It's been a long time since you've ever seen somebody repair an amplifier, or do you mean that you've never seen somebody take this long on an amplifier before? No, I don't think we spent that much time so far on this. I've spent like 8 hours on amplifiers before. Like on a single live stream, and then I'll spend another 8 hours on it on the next live stream, because I'm determined. I hate it when an amplifier beats me. I will not be beaten by some piece of Chinese or Korean electronics. No, no, no. No, 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 no. This is just logically working your way back. Like, I don't have any background experience with electronics at all. I'm just thinking logically about how this thing works, where there should be drive waves. If the drive waves aren't where I think they should be, work backwards, work out what should be sending it there, and then compare multimeter readings and see if one side is different to the other. If one side is vastly different to the other, then that might be the issue. So try replacing that first. I know this stuff can get really daunting. They're like a circuit board that you've never seen before, you never used to, never repaired before. You look at it and you're like, I don't know where the fuck, I don't know what anything's doing, I don't know where anything is. But just think logically about it. Think where the output components are. What's then tied to the output components. Just work your way backwards, and I guarantee that you'll probably eventually find some shit that's wrong. Okay, that's one. Okay, I think they're both dislodged from their connections now, from their vias. So let's pull this back over. Turn my iron off. Oh, I see, Jimmy. Thank you. I appreciate the kind words. Thank you very much, buddy. I see. I understand what you mean now. There's my camera view. There it is. So I'm just gonna ease her off the board. We're completely out of the vias now, so I can just do this. Should come out pretty easy. There we go. That's one. So that's the good one. That's the one that's potentially okay. And this is the one that's potentially not okay. So if we take that out as well. And now, out of circuit, what I'm going to do is compare the diode setting readings between these two. So, I'm going to put the two chips there, take my multimeter on diode setting, put it so we can both see. Okay, so what we were doing before, we were looking at now pin 5 is the output. So pin 5 is the one that's likely to get damaged if anything is going to get damaged. So I'm going to put my black probe on pin 5. I'm just going to go ahead and compare. So on pin 5 to 1, we've got nothing. Pin 5 to 2, we've got nothing. Pin 5 to 3, we've got nothing. 5 to 4, we've got nothing. So let's see if that should be the case. 5 to 1, nothing. 5 to 2, nothing. 5 to 3, nothing. 5 to 4, nothing. Okay. Let's try. This is where it gets difficult to probe it without the chip falling over all the time. 5 to 6, nothing. 5 to 7, nothing. 5. No, what? Where the hell is all the readings on this? Come on, give me. Here we go. Okay, 5. So 5 to 7. 5 to 7 should be 577. So these chips are out the board. So if it's anything different to 577, then one of them is doing something that it shouldn't be. Okay, 577 is actually the same. Let's try between some different pins. I'm going to go ahead and I'm just going to randomly guess. I'm going to go ahead and randomly probe different pins here to try and get some multimeter readings so that I can compare them and see what the jam is, see if these chips are actually different or whether they are the same when there's something else on the board that's causing the problem. These seem to be, these chips don't seem to have a lot going on inside them to measure. Usually you find stuff between pins to read quite easily on these chips, but huh. Okay, that seems to be the only reading. Between 5 and 7 seems to be the only reading that these chips actually give out. That's annoying. Alright, 5... Alright, so this way round, with the probes flipped, I've got 892 on the bad one. On the good one, I've got... Aha! That could be the problem. Right, so I have finally found some differences here. Oh no! Do you remember my old my live stream yesterday where I said about how I was fixing these LED bulbs? So it seems that the LEDs are just on their way out, but I make them last a lot longer than they would otherwise. Which one died this time? I think I see you. I think I see which one died. I think it was you. Was it you that died? You're very hot, so I think it was. Damn it. Anything? No? Okay. Oh, wait. We had something then. What? Is it going to stay on or is it going to turn off again? It's flickering. It's flickering. Makes me wish some of my amps still had channel playing. Done cooked them all. These lights. These are the bulbs for these lights, right? So they're just really it's a board of SMD LEDs, and then you've got a driver circuit over under here. There it goes. It's gone again. And yeah, they don't last very long, and they're quite expensive. So rather than buying new bulbs, what I've actually been doing is I've just been soldering new LEDs onto the board. So bear with me while I do that, because I need to do that. I need to see what I'm doing. So I'm just going to put the amplifier repair on hold for 1 second while I replace here. You can see the LED that died there. This one, the little one with the black hole. And these extra LEDs that I've put in, these are actually extra LED diodes in series. So this is just one long series chain of LEDs. And without any extra ones in series, it was killing them within like 5 minutes because they're all at the end of their life. So I added a couple more in series to reduce the voltage across each diode, which makes them last a hell of a lot longer. And the brightness is actually about the same, because although I've reduced the voltage across each diode, I've added an extra diode. So the voltage actually works out about the same. So the brightness works out actually quite good. Yeah, so let me just really quickly replace that and continue with our amplifier repair in a brief moment. So I'm going to take a donut LED off of this one. Where's my tweezers? Here we are. Evening, Tullius Tech. How's it going, buddy? Just doing some maintenance on my Stancast light bulbs so I can continue my amplifier repair. App Store. Hey, how's it going? If you're just joining me, I'm not doing a repair video on how to replace LED light bulbs, but I need to quickly fix this because I can't see what I'm doing and it just died on me. So bear with me, and we'll be back up and running after this short interlude. Come on, off you come. If anybody knows what these LED diodes are called, please let me know, because I would like to buy a whole load of them. Because at the moment I'm just I'm salvaging ones from this old board, because I don't know what they're called. They don't have any resistance and they don't read anything on the diode settings, so I have no idea what spec they are. I guess I could read the voltage across them. Problem is though, when they're turned on, they're so bright that I can't actually see what I'm doing to put the multimeter on them. So I need to load that up with some solder off the iron first. It's not going to go back on there nicely. SMD LEDs, yeah, but I need to know what voltage they are, what style they are, what spec they are. Because I want to order some more of these LEDs so I can continue to fix these rather than having to buy new bulbs, but I don't know what they are. So I can only do this for as long as they last on my donor board. Once they've run out on my donor board, I am stuck. Julius Tech gives me some advice. Awesome, I shall copy and paste that in just a moment. What I should really do is I should really backwards engineer them and read the voltage across each diode. But it's so damn bright that when I go to do that, yeah, when I go to try and read the voltage, like, I can't see what I'm doing, it's blinding my eyes. Seth says buy better ones and donates me $10. Cheers, buddy. These are meant to be quite good ones, that's the thing. These are meant to be really good bulbs. And they're quite expensive as well. I think they're like £12 each. So I'm not going to buy it. You know, if I can just replace the LEDs, that's the thing. There's no point buying new bulbs if the circuit, I would just be throwing away this perfectly fine circuit board inside here. I can just replace the SMD diodes, the LEDs, no problem. I just need to know what they are so I can just keep replacing them and then it's fine. That's the correct, efficient thing to do. Rather than throwing shit away that's not broken. Just replace the bulbs, don't change the whole circuit. So that should work now, fingers crossed. Ta-da! Good job. Alright. Now let's continue with our amplifier repair. So what I was saying was, I noticed that we had some inconsistencies between our potentially bad chip and our good chip. So what did I do? I had the black probe on pin 5 and the red probe on pin 7, and on the bad one we were reading, get this in view, 800 and something, 893. So if we take the good one here, do we measure the same or nah? No, we don't. So we should have nothing between that and that. So I would say that this one is dead, and I'm going to go ahead and order 2 replacement 2211s, and I wonder whether that will actually fix the issue. I really hope it will, and I'll be very happy. Cool. So until they come, unfortunately, I can't go any further with this amplifier, but I can continue with something else. Who was with me last night when I looked at the US amps? It was a Class D... Class DE? Class... It was something... They called it something different. I like helping when I can, even if the man takes his cut from super chats. Thank you very much, Seth. You're very kind. Seth donates all the time. Crazy guy. Yes. So we're gonna have a look at the another look at the we're gonna have another look at the US amps. So yesterday on the live stream, when we powered the US amps up, there didn't seem to be any issues, other than it dumped a really high amount of current into a 1000 ohm resistor. Was it a 1500 ohm resistor? I think it was a 1000 ohm resistor on the board, which was connected to the outputs of the FETs, after the inductors. So it was connected to the actual speaker terminal outputs and ground, and it was dumping a crazy load of current through that resistor. Excuse me. Now, the plan yesterday was to ask the customer what was wrong with the amplifier, why have you sent it to me, because it appears to come on fine and play audio. So I wanted to ask him what the issue was. He said that it sounds like pants. He said it sounds like a 500 watt piece of crap amplifier, has no guts to it, doesn't sound good at all, sounds rubbish. So what I'm going to do is bench test the US amps and just see how much power it makes, and see if it struggles to make power, if it draws excessive current or anything like that. Because it could be, with issues like that, it's very possible that it might have been an issue with the customer's wiring. But this guy knows what he's doing, the customer who gave this to me. He does know his stuff, he knows how to wire things properly. He runs big amplifiers, big subs, DDZ. He runs a pair of DDZ18s, or he has got a pair of DDZ18s, he just needs to run them. So he knows his stuff. So he wouldn't just wire something terribly wrong and then not think to check it if it was bad. So it's possible that there is a problem with the amplifier. The only way we're going to find out is do a bench test. So let's put our Rockford back on the shelf for the time being. Bye bye little Rockford, we'll get you fixed soon. I just need to order some new parts for you, my friend. Again, I've ordered lots of new parts for you. We're going to freshen you up so you're good as new. And then you can be appreciated by all the wonderful basshead community that love you so much, because people do love you. You're a good amplifier. Desolder my remote cable. Nice workshop. This workshop is stank. This is a fucking mess. But thank you. Yeah, I actually want to take a week off work and make my workshop beautiful. But I've got too much work to do at the moment to take a week off of work. So. Seth says supposedly it takes up the high frequency. I think Nicholas said that, didn't he, yesterday? Yeah. Yeah. Although I didn't notice any high frequency on it, which is weird. It's like on one side it had perfect audio, on the other side it had ground. I'd be curious to remove it from the board and just see what it did to the output, see what difference it made. Because yeah, if I lift that resistor from the board, if the amplifier stops drawing like 6 amps on without a speaker connected, then I know that's what's drawing the current. It might not be an issue, it could just be how it's designed, but I mean that resistor was reaching like 150 Celsius. Like that to me seems too damn hot. Like for a resistor to be reaching 150 Celsius, to me that's like that's something that's not right. And I only had it running for like a minute or something, with no speaker connected either. So I don't know. Samuel, inspirational. Cheers, pal. Thank you very much. That's very kind of you. Okay. Yeah, I sometimes have the outputs on as well when I repair the amplifiers, but this one, because the outputs of this Rockford amplifier are perfectly fine. Where did I put the outputs? Oh, here they are. Because the outputs on this amplifier are perfectly fine, and because they're such a bitch to take off of here, like, okay, it wouldn't be that hard, but you know, it would be some time. It would be some time to take these off. So because they're fine, and I'm pissing about with the drive circuit, I don't want to make a mistake and end up killing some of these. So I thought it was best to remove them entirely, wait until we've got good drive on both sides of this amplifier, and then put them back in once I'm satisfied. So away you go, back to the bench, back to the shelves, and let's get the US amps and bench test her. Damn, she heavy. I forgot how heavy this was. Now, this is actually in pretty immaculate condition, so I'm keeping it wrapped in bubble wrap on the shelvings. My workshop doesn't damage amplifiers. I don't let amplifiers get scratched, but because it's sod's law, it's just bad luck, isn't it? If you've got an amplifier that's in beautiful condition, that's the one that something is going to go wrong and it's going to get accidentally scratched. So I'm keeping it in bubble wrap to avoid that from happening. Beautiful, beautiful looking amplifier. It's like a kind of darkened, shadowy kind of smoked chrome effect. It's a lovely colour. It's a really nice looking amplifier. But I don't think it's a particularly good one. Although they are very sought after. Apparently they're quite rare and they go for quite good money. So yeah, it'd be quite nice to repair it if we can. If it's got a problem, that is. We're going to bench test it first to find out if it does actually have a problem or not. I need the SMD dyno machine. No, so the dyno machine, right, so the dyno machine is a clever piece of kit, but the dyno machine, you still need to have a fucking great big power supply to bench test amplifiers, right? So, bench testing amplifiers, big amplifiers, is expensive. It's fucking expensive, right? So, without buying the SMD dyno, you've already got to buy a power supply that is capable enough of supplying double what that amplifier would need in a car. So let's say you have a 5k amplifier. In a car, you might only need a certain power supply because after impedance rise, that amplifier is not going to be doing 5k unless you've got a really efficient woofer, or unless you are deliberately building that amplifier and subwoofer setup to do a burp note, and so you're maximizing the power from the amplifier. When you static load bench test an amplifier, you are literally drawing like so much more power, and the amplifier draws a lot more power than it would ever do in a car. So your power supply in the workshop needs to be horrifically large. At the moment, I've got a few different things going on. At the moment, hooked up, I've only got 2 server power supplies. I can draw about 400 amps at 12 volts from these two. So that's not too bad. I can safely bench around about 5k. But it's not 14.4 volts, so I have to use correction factor to work out what it would have done at 14.4 volts, because I can't get these to to reliably boost voltage. I can get them to boost up to 14 volts, but they don't actually give any current at 14 volts. As soon as you draw current from them, it sinks back down to 12 almost instantly, so that doesn't work. I do have some other power supplies, some HP ones rather than Dell ones, that do work at 14 volts. They're a bit less powerful than these ones, but having 14 volts on tap will allow me to hook up my bank of supercapacitors, which I've got over here. I've got 2 banks of supercapacitors waiting to go into the power supply in the workshop, so that will help out, obviously, because especially since my bench tests are generally bursts, they're like and off, so the supercaps will be very good at helping me out with that. And I have a lithium battery ready to go as well. So lithium battery, supercaps, 2 banks, and 14.4 volts at 400 amps roughly. I should be able to bench test pretty much anything that you can throw at me. But they all get very expensive. Supercaps aren't expensive. Lithium batteries are supercaps are expensive. Lithium batteries are expensive, and yeah, you have to wire it up and know what you're doing. So my point is that you've got to do all of that and spend out all that money on a big power supply, right? Once you've got a big power supply, all you then need is some dummy loads like this, some big static loads that you can dump power into that will stay the same resistance, and that's all you need. Then you just need Ohm's law. You have a static load, you can measure voltage RMS, so you can work out power watts RMS. What the amp dyno does is it does all the calculations, and it has the dummy loads inside it, and it does all the calculations for you, and it also it generates the frequencies and the sine wave and everything for you. So the amplifier dyno will cost me something like £2,000, okay, and all it does is it will replace my oscilloscope, my frequency generator, and my dummy loads. There's a lot better things I could spend £2,000 for to make my workshop and make my life easier and make my repairs better. Spending £2,000 on an amp dyno would not make my amp repairs £2,000 better, or make my content £2,000 better. All it would confirm is it would confirm that my bench testing methods previously are accurate. That's all it would do. I know that you get the little screen that says dynamic and certified and all that crap, but here I am testing real power, real watts RMS using standard Ohm's law into static loads, using volts RMS to work out watts RMS. I don't need to do anything more to confirm that amplifiers are working properly. If the SMD amp dyno was like a few £100, then maybe I'd be tempted, but at £2,000, hell to the no. Now, is this amplifier a 1 ohm amplifier? I can't remember. Didn't you scratch the fly when you swatted it? Nah, I used some paper. I used a roll-up poster. If a roll-up poster can scratch an amplifier, the amplifier is made of cheese. You need the SMD dyno to test RMS. No, you don't. App Store, you don't need the SMD dyno to test RMS. No. You test RMS power by having a device that can read volts RMS and a static 1 ohm load, or a static load. If you have a static load and you have a piece of kit that can measure volts RMS, then you can calculate watts RMS. You don't need the dyno. So yeah, is this US amps 1 ohm stable? I don't want to plug a 1 ohm load into it and then it explode on my bench. What is it? US amps. What was the model number? I can't flipping remember. It's 32 something. AX3200DE. Are you 1 ohm stable? Probably are. Yeah, 3000 watts RMS at 1 ohms. Okay, cool. Good. So let's hook up my my test loads here then. These test loads get a beating. They discharge rail caps all day. And whoa. Oh wow, there's a fantastic echo that goes on. I was talking loudly next to the floodlights, and it resonates with my voice in this really kind of eerie, fantastic way. That sounds really cool. I'm gonna have to record that at some point. What was I saying? I can't even remember now. There we go. Here's the one I need. What are those rectangular 1 ohm static loads I keep referring to? They're exactly that, my friend. They're exactly what you said. They are static loads. Static loads, well, it's just a big it's just a fucking big resistor. So this is just a really, really big resistor. And I have four 4 ohm really big resistors. So in parallel, that will give me a 1 ohm resistor. These resistors are 4 ohm, 1000 watt continuous. And because they're 1000 watt continuous, I can actually dump a crap load more into each one of them. I think the burst rating of these is like 3 or 4k per resistor. So I've got more than enough static load to bench test really big amplifiers. They do get really hot though. They get really, really quite hot. But the heat is very, very delayed. So they have immensely huge thermal mass, which they obviously need to. In order to dissipate 1000 watts each, they need to have crazy high thermal mass. And so if I do a big bench test or I do an endurance test using these, then like if I'm dumping say like 3k into the 4 of them, for the first 5 minutes they'll stay cold. And then so if let's say I do a 5 minutes worth of testing, they will stay cold for 5 minutes. I'll turn it off, but then 10 minutes later they'll be red hot because there's so much thermal mass. It takes that long for the heat to come from the actual resistive coils inside to the outer heatsink. Do you know anything about Phoenix or Phoenix audio subs? No, not something we get over here in the UK, so I've not had experience with those. What happened to your old yellow Optimas? Oh, holy crap, that's fucking years ago. Yeah, those yellow Optimas, I had 4 of them. 2 of them were actually in very bad condition when I bought them, so I sold them for cheap. I sold them as not working. And then the other 2 I used in my car for a couple of years, or not even a couple of years, probably a year or something. But yeah, the Optima yellow tops, they're pretty crap these days because all the good Optima yellow tops, so all the good ones, are now so old that they are all dead. And the new Optima yellow tops are made in China. Well, I think they might, I don't know, might have already been made in China, but anyway, the new ones suck. Apparently the new yellow Optimas suck. They either suck or other batteries have caught up with their technology and are now better than them. So yeah, the Optimas apparently are no good anymore. So yeah, I sold those on. I sold those for really cheap actually. Positive input. I thought new Optimus made in Mexico. I have no idea. Actually, this could be a while ago. So when I say the new Optimus made in China, like I was told that information probably 5 or 6 years ago. So I have no idea where they're being made now. So that could be completely invalid information. No idea. If that's the case, and if Optima are now making new batteries in Mexico, I have never tested them, so I have no idea if they're any good or not. So they could be quite good. No idea. But there was for a while the Optimas weren't any good. That I was told, so I never bothered buying any more of them. Excuse me. I definitely just coughed right into the microphone, so that probably would have been quite loud. Sorry. Got a bit of a sore throat at the moment. I'm not too sure why. I'm definitely coming down with something, but I'm trying to just ward it off. Okay. So what do we reckon? I always like to get people to guess what's going to happen. So this amplifier came in. Apparently, the customer says it sounds like pants, sounds like whack, and doesn't make any power. Sounds like a 500 watt amplifier. So it comes on, it makes audio. What do you reckon is going to happen? Is it going to work? Is it going to bench test? Is it going to bench like around 3K? Or is it going to bench like 500 watts and draw excessive current? Or is it going to explode? I would really hope it doesn't explode, because the amplifier is kind of in a... Well, it works, it makes audio, so if it explodes, then we've gone backwards. Speaker Free says it's going to catch fire. No, man. Oh, man. Lots of people think it's going to blow up. Oh, man. Before I do testing, I usually check the power supply and output transistors. Yeah, man. Yeah, Jimmy, we did that. So yesterday we had this on the bench, and we yeah, I went through and checked everything, and I couldn't find anything wrong with it, and it made a nice clean audio signal. So none of the FETs were dead, none of the resistors were dead, none of the drive circuit was dead. So doesn't seem to be anything wrong with this on an inspection level. So the only way to tell now is to drop a bench test. That resistor where you were telling us about will catch fire. See, that's interesting. So the resistor that was getting crazy hot on the board from yesterday, that's a 1000 ohm resistor, and it seems to sit on the speaker output and ground. So it's basically we're powering a 1000 ohm resistor with this amplifier at all times, and it was getting like over 100 degrees Celsius, which is a little bit confusing and unusual, but apparently it's supposed to be there. Now now that we've got it hooked up to some dummy loads, okay, the dummy loads are obviously a much lower resistance than that resistor, so technically the electricity should favour the lower resistance path, and that 1000 ohm resistor might actually not get as hot. I could be chatting absolute bullshit, and it might... no, hang on a minute. No, it probably would get the same... It probably would still get the same hot, because it's still in parallel, so it's still going to be dissipating the same amount of power through it, even though we've got the dummy loads connected up, so it probably still will get hot. It is a big resistor though, so maybe it's just meant to get hot. I don't know. We'll see. We'll see. Okay, power supply's hooked up, so now I just need to plug the RCAs in. Just going to reference my input board here, so let's have a look. Inputs are on the left hand side, sorry. This is upside down, so the inputs are on the right hand side now, this way around. So inputs there, and we need to turn the gain down to 0. Crossover frequency, we're going to turn that down a bit, and up a tiny bit there. Bass EQ we need off, subsonic on off. Alright, cool. So let's turn her on and see what happens then. A good question for you. Do you think power caps are a waste of time for small voltage drop, dimming lights or amps turning off at high volume? So using a power cap to stop your dimming lights is you're just masking the issue. So you can, if what people used to do is if you had a subwoofer set up in your car and your headlights were dim, you can put a capacitor near the headlights and it stops the headlights from dimming. What it doesn't stop is it doesn't stop the voltage drop at the amplifier. Now, like a 1 farad, 2 farad, 5 farad capacitor is never going to be enough storage to make a noticeable difference really during long bass notes when you're powering your amplifier. Super capacitors are very good at that because they do have a big enough storage capacity to make a noticeable difference when you're playing big systems quite hard. You're popular tonight. I have faith in you. Thank you, Seth, again. Thank you, Seth. How many are watching tonight, actually, interestingly? Is this a popular stream? It seems to be a lot going on in the live chat. Yeah, we've got 68, so not a huge amount. I think the most I've ever had watching was like 119 at one time. So, positive speaker terminal, here we go. Let's pop that in there. Okay, next, I think that's it. I think we're good. I think we're ready to go. Turn our supplies on. Oh, holy crap. OBS is dropping frames like a boss. One sec. Ah shit, why is OBS dropping frames like a boss? Wait, one second, what's going on here? I think maybe my computer was trying to do something. Seems to have stabilized itself now. So yeah, OBS seems to is dropped 3,000 frames just now. That's quite a lot of frames. Yeah, I just closed some of my web pages. So okay, cool. Now we're ready to go. Let's see what the flipping hell happens with this thing then. Let's turn my scope to the correct settings. Turn reject high frequency. Turn her on. Put my fingers over my ears. Okay, so we have a sine wave on the screen here. Cool. So I'm going to go ahead and keep increasing the sine wave until we reach clipping point. And one thing I forgot to do was to plug my multimeter in to the power terminals so I can see what voltage it is dropping to. So I don't have a current sensor on this. So I don't know how much current these things are drawing. But I can guess how much current this is drawing by the voltage drop. So I can see how much voltage drop is across the power supply, and I can get a good idea as to whether this is drawing the right amount of power or drawing excessive power. So let's see. Okay, so that is our clip point. And our voltage drop is at 11.8 volts. So actually, so far, this is actually looking pretty respectable. This is actually looking like it might actually be doing rated power. So it looks kind of dirty at the top of the wave here. So I let it go into a bit of clip. This is probably about 5% THD. So you can see as we reach the top of the rail, it's very hard to see because my scope cam is a potato. But there is, I need to get a better scope cam. I'm going to get a better scope cam very soon, don't worry. At the top of the wave here, there's some jittering at the top and the bottom, and that's what happens when the sine wave reaches the rail voltage. So let's go ahead and make some calculations. It sounds kind of janky when it does the power though. It makes a buzzing sound. It doesn't sound very nice when it makes power. So let's see. So this was at 11.8 volts, okay? Just bear that in mind. So this is at 11.8 volts. We saw 43.77 volts at 1 ohm. So that just did 1,915 watts at 11.8. So we need to work that out for correction factor for 14.4 volts. So we take 14.4 divided by 11.8 equals 1.22. Square the result to give us our correction factor based on square law, which is 1.489. Times that by the power that we saw, 1915.81. So this just made 2,853 watts RMS, 0.07. Into 1 ohm. So yeah, if we managed to hold 14.4 volts, then we would have seen 53 volts on the rails. So yeah, it's definitely making like close to rated power. This amplifier is different to it claims to be different to a standard Class D. So it might have a slightly different ratio of power from low voltage to high voltage. So if I did put 14.4 volts in it, the square law correction method might not be the most accurate for this amplifier. It doesn't feel hot. So yeah, if we did hold 14.4, it might have done the 3K. But to be perfectly honest, I don't rate these amplifiers. I don't think they don't seem very good. There's not very much going on the circuit board. The circuit board's very empty. So for any of you guys that weren't with me on the live stream, I'll turn the board over so you can see the circuit board, okay? So you can see what's inside this thing. Let's disconnect her from the supplies. What we got going on in the live chat? Hey Sam, you got to sweet talk her before you turn her on. Yeah, US amps has definitely become poop. Yeah, the old US amps used to be good. I do have a beautiful old school US amps in the workshop, and for any of you who haven't seen it yet, I'll show you in just a moment. But first of all, I'm going to show you. So let me show you the internals of this US amps first. Okay. So I'm just going to unplug all my dummy loads and all that crap that's probably going to fly off the desk if I try and turn this over without unplugging it first. Let's take that out of there. Put down there. So flip her over, and inside of here we have so yeah, this is the board that does 2.8K that we just bench tested. So Looking at the output devices here, these are MOSFET devices on the outputs. It's not a weird class kind of GH, class AB, it's a class D, but US Amps have tried some marketing gimmick by calling it a class DE. There doesn't seem to be much different with this. This is a really old style class D. We've got a pair of op amps up here in the top corner. We've then got a bunch of drive circuit here, A92, A42, A56 transistors, which then feed the main output transistors, and it really is nothing special. And the build quality is pants as well. These inductors are not seated down to the board properly by any means at all. So if you mount this thing to your subwoofer box, these inductors are going to flipping snap off the board in no time. The transformers are a bit better. We've got a bit of CA glue on those, but they're still not great. And probably the reason that they haven't decided to put anything around these is because this has a perspex back. So the idea is that the amplifier looks beautiful from the back, which is all well and good. Like, okay, I get if you want to make the amplifier look beautiful from the back, but what's the point, like, if it's gonna die because it gets vibrated to shit? There was a small resistor here that we found that seemed to be missing. So when we looked at this the other day, over here, I'm going to bring the board into view rather than trying to get the camera. So there's a resistor over here, okay, R64. Now this seems to, at one point in its life, have had a resistor on it, because it looks like there's some legs, some leads. Now I probed either side of this resistor, and there didn't seem to be anything on either pad. So I don't know, without a schematic, I have no idea what the flipping hell this was for. I could probably work it out by tracing back through the circuit, but I really can't be bothered with that, I ain't got time for that. So yeah, it seems to work fine without it, but I don't know what it was for. But that's the only thing that I can see that could be potentially wrong with this amplifier. It does pretty close to rated power, which is what I'd expect. I didn't expect it to do more than rated power because it doesn't seem to be a very good amplifier. So I'm content with the power that it makes. The only thing that I've got that I can do now, the only thing, you know, in order to fix an amplifier, I've got to find a fault with it. If I can't find a fault with it, I can't fix it. So if this amplifier does the power that it's pretty much meant to do. It does 2.8K, which is acceptable. The only thing that I've got left to do now is do an endurance test to make sure that it can do its 2.8K over a long period of time reliably. So yeah, I'll put this all down to one side and I'll do an endurance test at some other point. But for now, it can go back. It can go back in its case. I can't just stick any old resistor in that because I don't know what value the resistor should be. That's the problem. Fernando says he reckons one of the RCAs was not in their correct position for the punch amplifier. You might be right, actually. Although, actually no. I would normally say yes, you're right, but the punch amplifier is a monoblock amplifier, and the pre-amplifier stage, it parallels up the inputs. So it's not like a two-channel where you need a bridgeable two-channel where you need both RCAs in order for the two sides of the Class D to work. The amplifier is a mono amplifier, and it has half rail voltage on each of these speaker terminals, and it swings the audio wave. The resting ground point is half rail. It swings the audio wave up to top rail and down to ground. And so in order for that to work properly, both of the sides of the Class D mono need to, both plus and negative need to work. And it can't be, if it was the case that having only one RCA in the amplifier caused that to happen, then any time you plugged one RCA into the amp would blow the whole thing up. So it's definitely not that. It definitely is a dead 2211 because one of them reads different to the other. So it's definitely a dead component. not the fact that we only had one RCA. But I like your thinking. It's a good idea. It's logical thinking for sure. Down there for a sec. Slide her back in place. Oh, it's a bit tight there. It's a little bit tight there. Back in. I have some Nakamichi stuff in the workshop as well, interestingly enough. Okay, so what screws do we have here? Are these the screws for the US amps? I've got 2 long, and I've got 1, 2, I've got 4 short, I've got 3 long. 3 long, 4 short, and 4 bolts. So 1 long goes in the RCAs. Yeah, I'm just going to put this amplifier back together real quick because I want it all back together. I don't want to lose any parts for this thing, so I'm just going to real quick put it all back together. I think I see what the long screws are for. Yeah, I see what the long screws are for. Never mind. I do have all the screws here. And then once I've put this thing back together, I'm going to show you an old school US amp so you can see the difference in build quality between the old and the new. I do have to repair this old US amps, but I kind of keep putting it off because it's going to be an absolute headache to repair. Purely because the amplifier is so long. My workbench isn't quite long enough to repair it just yet, to get it all on the bench. What's stopping this from going on? There's something stopping this end plate from going on properly. Why you no go on? Why you get stuck? Maybe it just needed a bit of encouragement. So yeah, sorry this is a little bit boring this bit, but I want to get this back together so I don't lose any parts, and then we'll move on to something interesting. What can I move on to next, I wonder? I think next I'm going to move on to an SPL Dynamics D... I think next I'm going to move on to an SPL Dynamics D5. Who would like to see an SPL Dynamics D5 repair? Okay, so that's all back together. Back in the bubble wrap she goes, and yeah, I'll do some endurance testing on that. But provided it passes the endurance testing, I'll just say to the customer that it's fine, and that the reason it sounds like wank is because it's a pretty crap amplifier, and he should just sell it because they are quite sought after, and he should buy something different. Actually, he has lots of different stuff anyway, so he doesn't need to buy anything different. But okay, SPL Dynamics D5. Here we go. So, this amplifier was, I've actually had this one for a little while now, and it was giving me a couple of headaches, and I thought I'd repaired it. Why do I have LEDs in this bag? That's all. Anyway, I thought I'd repair this amplifier. It seemed to work great outside of the case. I put it back in the case and it worked for a bit, but then it started going weird, and yeah. So yeah, this amplifier I did a repair on quite some time ago, but it doesn't seem to be happy now. It's sprung some new issues, so we're going to revisit this and see what's going on. I've never done this on live stream before, this one, so this is a new one for the live stream. This amplifier has definitely been taken apart and put back together many times before, and been repaired many times before. It's got all sorts of flipping dodgy solder traces and stuff where previous technicians have repaired it before. It's a bit of a hot mess. Ah, come on, damn it, come out of here. This amp's pretty packed out, yeah, there's a lot of stuff going on in here in a relatively small package. fucking hate these clamps. Sorry headphone users, that's probably quite loud. I need to get these damn clamps off. Yeah, the clips which are a pain to get off are always the ones which are on the which are on the rectifiers. Because the rectifiers are usually by the capacitors, the rail caps, and they are a massive pain in the arse to get off. Absolutely massive pain in the arse to get off. Especially if the rectifiers are soldered very, very close together, you can't get an Allen key or anything in between them. So what I'm doing at the moment is I'm actually just I'm just gently shifting the clip over to a blank space on the board, so I can then get a clip in there. Where can someone get those clips? Good question. I've never needed to find anywhere selling these. If I need some spare ones, I usually just get them from my donor amp that I've got laying around, something that's not worth repairing, that's too far gone or something. The customer doesn't want to pay for the repair. But I'm not too sure where to get these from if you need some fresh, like brand new. I'm not too sure. It's a good question. Random flat shadows. So if you just logged on, you have missed bench testing the MTX Road Thunder 501. That made 559 watts RMS at 1 ohm, 14.4. We then had a look at the Rockford Fosgate BD1500 and found a potentially dead 2211 chip. We saw we had good drive wave on one half of the amplifier, but the other half we traced back and there's a potential dead IC. So that we're going to order some parts for and continue with that at a later date once they arrive. And then we had a look at a US amps AX, what was it? AX 3200 DE. And we did a bench test to make sure that it was working. Can't seem to find the fault with it, and it does 2,850 watts ish. So that's probably working fine. I'll do endurance tests on that to confirm, but it appears to be okay. And now we're just moving on to an SPL Dynamics D5. This is not the D5S, the street version. This is the higher voltage version. Okay, let's see if she'll slide out it now, if I've missed anything. Have I missed any screws perhaps? Let's see. Got one there, one there, one there, one there, and that's it for screws. So we should, yes we do, we slide out in this direction. Okay. And we have these really annoying RCA wires. So I'm actually going to need to take those off. So yeah, this amplifier has the RCAs. It has them just with wires onto the board here like this, which is really kind of annoying because they snap off when you're working on the board really easy. So we're just going to have to take extra care on those, or we can just desolder them and just reattach them after we finish working on the amp. That might be the best thing to do, because otherwise we've got this great big metal plate hanging around whilst we're trying to repair. Okay, let's get rid of the heatsink. Oops. And up she comes. So we need to start from the very bottom. Like I said, I did do a repair attempt on this a while ago, and it seemed to work fine. Then I put it back in the case, and then it kind of was doing weird shit. So we need to find out what's going on and why it's not happy. This amplifier has had many repairs done to it in the past, as we can tell by the amount of shit that's soldered and on the board and other things. So yeah, it's had a hard life. It's been repaired many times. Not too good. So, first things first then, let's power her up and see what we're dealing with here. If I remember correctly, there's no blown FETs. If I remember rightly, there's no blown FETs. Yep, power supply charges quickly, so nothing going wrong in the power supply. Output section. Output section seems okay. Okay, I'm just going to check the underside of the board in case there's any solar flux that's left, because I think I repaired this one before I realised that my solar flux was conductive, so it could be something to do with that. So I'm just going to flip the board over and just make sure there's no remaining solar flux. If there is, we'll clean it off. Let's have a look. No, looks pretty good there. The drivers don't have any solar flux on them by the looks of it. We'll give it a clean anyway, because it's good measure to give it a quick clean. And the output section looks pretty janky. So many previous repair attempts on this board. It's ridiculous. It's like this has been absolutely mutilated by so many different repair techs over the years. Okay, cool. Seems to be alright. So back over we go. Look, see, I've already snapped one of these flipping wires. I'm actually just going to desolder all of these because this is going to drive me nuts. It's going to drive me absolutely nuts. So I'm going to desolder all these wires from the board on this end plate because they're all going to snap. It's going to drive me crazy. Alright, that makes life a lot easier. Okay. So let's put some power to the board and see what she does. That's how positive. Gonna shove that in there just very quickly. Okay, reset my scope from my bench test and change it back to the correct settings for measuring drive waves. That's about right there, and reject low frequency. Get my probe, switch her on. Okay, let's see what happens. Okay, looks like we get a power supply drive wave there. Ooh, the frequency is a little bit all over the place. Don't know if you saw that there. The frequency of the... Whoa! Whoa! What the fuck? That's flipping awesome. So, the frequency of the power supply switch is going all over the place. You see that? That is not happy one bit. Okay. Okay, we need to check out why it's doing that. It does eventually sort itself out. But something's going from the board. I wonder if anything is heating up. How much current does it draw when it does that? Like, it's drawing a lot of flipping current. It's drawing like 3 amps plus. Okay, what's getting hot? Anything? Pull down resistors getting hot. Okay, that's to be expected. Anything else over here getting hot? Maybe on the driver board itself? Okay, nothing on the driver board itself is getting hot. So I think that we have some kind of resistor or capacitor that's responsible for some jazz on the driver board is playing funny business. Now, I've not had to do a great number of repairs on these power supply driver boards before, so this could be new territory for us. Okay, wow. I'm going to let that do that again. I'm going to try and work out what exactly is going on when it's doing that. Whoa! That's a nasty, nasty sound. Yeah, the frequency just shoots right down. Right. I think it's time to remove that power supply drive board for sure. And firstly, we need to discharge the rail caps. Tony Baker, yeah, how's it going, buddy? Wicked Wednesdays. Yeah, who remembers that? Wicked Wednesdays. I did come up with names for all the days, but I can't remember what they were now. Wicked Wednesdays. Yeah, we've done quite well this evening. Okay, discharged, that's all good. So now I need to go ahead and firstly remove that power supply drive board. Because I think that's where the issue lies. It's whatever's in charge of generating the switching frequency is not happy. So see, now the camera looks too underexposed. You see, before it looked overexposed. Now, hang on, now it's coming up. That looks better now. Now it looks underexposed again. suck all the solder, and then we're just going to hang it off the desk for temporarily. I'm going to wiggle the board so that the legs of the board get really wobbly in the holes, so that they're not connected to the veers anymore, because we don't want to pull the veers out with these legs. So just push the legs away from the sides of the holes, get them free from the veers. Mostly all done now, just got number 1 to do. Number 1 and number 7 need a bit more sucking. Okay, we should be good now. Where'd you get the silicone tip that fits on the end of a solder sucker? It's actually the silicone tip that comes with my soldering iron tips. So my soldering iron tips, they come with a little silicone tube over the end of the tip. I guess it's just part of the packaging of, to protect it from new. And that tip just very conveniently happens to fit perfectly over the end of my solder sucker. So I guess you could get the silicone tube from like eBay or Amazon or something. I don't know, some kind of hardware store perhaps. Cool. There we go. Driver board is out. So what I'm going to do is, yeah, let's have a quick look on here. What have we got going on here? Okay. Now if I zoom into the driver board, we can see that this driver board contains a very common friend. This chip here is the TL494, which is going to be very, very hard to make out. Let's see if I can zoom in a bit more. Is it going to focus? Is it going to focus on this? I think that's about as close as we're going to get with the focusing. So yeah, this is our TL494 chip. And if we have a quick look, so I know where they are, but this is going to be interesting for you guys. It's going to be interesting for you guys. So I'm going to go ahead and we're going to have a look at the data sheet for the TL494, okay? So if we have a look at the data sheet for the 494, the issue with the amplifier was that the switching frequency was all over the place. It was going super duper low. So if we have a look at this, we have a look at the pinout. Okay, so this is the pinout of the TL494. So what pins on this are responsible for setting the switching frequency? So pin number 1 and 2 we know are the inputs for error amplifier, and 3 is the output of the error amplifier. Pin number 4 is the dead time control, it's not that. Pin number 5 is going to be where the sawtooth wave is present on. So if we look at pin number 5, we can see here that this is capacitor terminal. Ah, here we go. Capacitor terminal used to set oscillator frequency. Okay, so there will be a capacitor on pin 5, and RT number 6, which is down here, resistor terminal set to use oscillator frequency. So these are the two pins which are used to set the oscillator frequency. So if there's a problem, then it may be to do with the resistor or capacitor or both on these two pins. So the first logical thing to do is to replace both the resistor and capacitor on pins on those two pins there. So if we zoom into our board, we can see that the two, oops, wrong camera. So where's my multimeter? So pins 5 and 6 have a resistor and a capacitor on them, which sets the oscillation frequency, which was the thing that was screwing up. So if we go ahead and look at pin number 5, 1, 2, 3, 4, 5. Pin number 5 here. I need to be able to do this so you guys can see what I'm doing. 1, 2, 3, 4, 5. Pin number 5 here has a capacitor on it, which is here. There's a small SMD capacitor, which is here on the board, and pin number 6 has a resistor, which is just here. So I'm going to go ahead and replace these two components, this resistor and this capacitor, and see if that helps. I do fortunately happen to have a spare resistor and capacitor for these. I have a bag here which has a resistor and capacitor just for that. That sets the oscillation frequency to around about 25 to 30 kilohertz, which is the correct frequency that we need. These parts are incredibly tiny, so I just have to be very careful taking them out of the bag so I don't lose them. Okay, there's our very, very special resistor. Now, there should be a very, very special capacitor in this bag as well somewhere. Ah, it's attached to the back of the chip that's in here, so let's get this chip out. Come on, out you come. Don't be shy. You're going to do some good power. There we go. Okay, that's our capacitor. Now, I can't remember the exact values that this capacitor needs to be. The resistor is a... what is the resistor? Resistor appears to be a 2202. So that is a 22 kilo ohm resistor by the looks of things. So we need to go ahead and zoom into this board, and we need to remove the existing capacitor and resistor using our hot air station and replace. Yeah, I'm not too happy with the gain on this camera now. I'm going to try and just whilst the hot air is heating up. I can't remember the value of the cap. Sorry, guys. I honestly can't remember. I could probably read it on the I could read it on my tester. Yeah, I'll read it on my tester and find out. There we go, I think that looks a bit brighter. Okay. I'm going to drop a little bit of solder flux. And turn my air pressure down. We only need really tiny air pressure on this. And there's a capacitor in the way so you guys can't see, so I'm going to try and spin it that way so you guys can see what I'm doing. You still can't kind of see. If I spin it that way, that might be the only way you guys can see. Okay, resistor is off. Capacitor is off. So just before I load up the new capacitor, I'm going to see whether I can measure the new capacitor on my tester, just out of curiosity to see what value it is. I'm going to try not to lose it while I do this. It's also going to be okay. So it looks like it's 125 microfarads. ESR is 40. Oh no, what? ESR is 0.14k. What the fuck? Doesn't sound right. Voltage loss is 60%. Okay, doesn't sound right. Now we have 724 microfarads. Oh, okay. Either this transistor tester can't test it, or there's something going horrifically wrong with this capacitor. I wonder if the TL494 datasheet has a list of capacitor. Now back to 121 microfarads again. I wonder if the datasheet has a list of the capacitor values required for different frequencies. Let's test the capacitor that was just in there. Let's see what that reads. The capacitor that was in there, that I just took out, that one reads. What the flipping hell? That one doesn't appear to read anything. So maybe, I think this was the bad, I think this capacitor was bad. My fingers are touching it. Yeah, I can't get away from that. I can't get away from my fingers touching it. So this capacitor I just took out the amplifier appears to be bad. It's not reading any capacitance at all. So that might be the issue. But I can't seem to reliably read this tiny SMD capacitor because my fingers are touching it at the same time. The only way to get around that would be to SMD solder it onto this board. I could do that actually, yeah, fuck it. I'm gonna SMD solder the cap to my tester board. So we've got our tester board just here. So let's just drop a little bit of solder onto the pads here. Solder her on. That'll make testing these things a bit more reliable going forward. So yeah, put some solder onto these pads. And I'm just going to drop the capacitor in place. There we go. I need to zoom out a little bit because it's a little bit blurry. You guys can't see what I'm doing. There we go. So you can see the capacitor is now soldered in place on my tester. So if I use my tester now, it should just give me the most accurate reading possible for this. If I use tweezers, it's going to fly off the flipping board. Interesting. It doesn't actually read anything. It doesn't measure anything. It's like it's reading a gradually increasing PF. Weird. Okay, what I might have to do is I might have to see if I can find another power supply driver board from a donor amplifier, and see whether I can. I don't have to use an SMD cap. I can use a bigger cap if I put it on the board and solder it to the pads, just as long as it's the right value. Yeah, this capacitor ain't reading shit. This capacitor's now consistently reading 1098 PF. I don't know if that's right or not. No idea. I'm going to measure the other one. I'm going to solder the other one to this tester as well. Because I am curious to see. Ah, they do actually both measure the same. So they both measure the same. So obviously my fingers are screwing things up before. Yeah. Okay, interesting. What I might do is I might see if I can take a cap from another board, some other donor board, and just see what that one reads as. One that I know that works. What have I got over here? Some donor boards, perhaps. Yeah, let's have a quick look at a really small, crappy donor board. So I've got down here some kind of vibe piece of thing. So I've got this vibe donor board here, and does this use a? Let's just check. This is using a. Oh no, shit! This uses something different chip. This uses a KA3525. Okay, how about this edge amplifier? So this is using through-hole components, but we should have the same basis. So if I find which capacitor is on pin 5, this TL494, 1, 2, 3, 4, 5. Is this the same number of pins as the SMD one? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, it's the same number of pins. All right. So if I find the part. 1, 2, 3, 4, 5. So we need a resistor and a capacitor, which is on pin 5. One, 2, 3, 4, 5. Ah, you won't believe it. I actually removed the capacitor already from this board in that location. That's frustrating. Okay, let's find another donor board. Okay, let's take a JBL GTO 1200.1 for the time being as a donor. I actually would quite like to get this amplifier fixed. It's got some driver board issues that are driving me nuts on the output section. But let's remove the power supply driver board from this amplifier and use some of the parts, because I know the power supply is actually good in this amplifier. So we can compare the readings and stuff from this amplifier to the other driver board. This driver board is going to be a fucking nightmare to remove. I might have to choose a different board. I don't want to spend ages on this. Nah, that's going to take fucking ages because it's high thermal mass. I can't be bothered with that. Let's find something different. Let's try this piece of junk US amps. This is different US amps to the one earlier. So let's have a look. Power supply is good on this one as well. So pin 5 and pin 6. TL494 is nicely hidden under this crap of wires, so let's remove that clip there so we can get to the wires. Get to the TL494, there we go. There you are, my friend. So the capacitor 1, 2, 3, 4, 5 appears to be a, so Ermatus, can you help me out here? This capacitor is a film capacitor and it says 102J63. J63. And the resistor is in fact a 22 kilo ohm. So the resistor needs to be 22 kilo ohm. Ah, this resistor was 19.4, so that's a bit too low. This resistor is 21.8, so that's about right. So I'm going to solder this resistor back into the board, because this one appears to maybe be okay. So 102 is 1000 PF, so those capacitors were actually okay. Fuck, so what's the issue then? Maybe the TL494 is screwed up. Oh no, I just put the resistor down somewhere. Where did I put it? It's disappeared off the table. Because it's so tiny. Uh-oh, where's it gone? Uh-oh, where did I put it? Oh shit. No. Did anybody see where I put it? It was on my finger. I found it. It's so small I can't actually see it on the table. It's so flipping small I can't actually see it on the table. Right, okay. And the capacitors were reading fine, you said. So let's put the capacitor on. Okay, so it's possible that the 494 is dead. What I'm going to do is, because I did replace the resistor there, the resistor was a slightly incorrect value. I don't know whether it would have caused that crazy issue, but I'm going to clean the whole board with alcohol, just in case there was some old solder flux or something from some other previous tech that screwed this up. So I'm going to clean this off. Excuse me. Alright, now, because I don't know whether this driver board's still good or not, I'm going to put it in some headers. So I can quickly remove the driver board as and when needed, because it's obviously got some issues. Let's find a strip long enough to fit. Ah, look at that, perfect fit. First time. First time. Okay, solder the headers in. Once we've soldered the headers in, I can put the driver board into the headers and we can see if the issue stops or if it carries on. If the issue carries on, I guess I'll try changing the 494 next. It's a little bit annoying because it's very hard to actually read the 494 in the circuit because it's on an angle. Okay, let's try this now then. See if that's made any difference. Slot her in. Make sure we get the pins in the right place. Actually, I'm just going to tidy off the pins on here a little bit because a couple of these pins are a bit bulgy with solder. Just in case any solder drops into the board there. Okay. So, did that make any difference? I don't think this is going to have made any difference. I don't think the components were that far enough off. So I think we're probably going to have to change the 494 in just a moment. Not going to sleep tonight. I'll sleep at probably 2:30 or 3. Okay, let's see. Did that make any difference? Ah, wait. Huh. Let's turn her off. Turn her back on because it was the second time we powered her up that it was bad. Okay. Alright. Not bad. That seems to have solved the issue, perhaps. Potentially. It's a little bit jittery on the scope. Can you see? I don't know what causes that. I see that sometimes. It's a bit jittery. I do see that sometimes. I don't know what causes it. But I'm happy with that. The amplifier seems happy. It's not heating up, etc. So, okay, cool. I think that's the power supply sorted then. Now let's have a look at the output section. Now, if I remember correctly, the output section was doing something fucking strange. Okay, so if I remember rightly, we had a bank of output FETs here on the board. Let me flip my camera over a little bit here. If I remember rightly, we had a single bank of outputs on the board here that were heating up, and they were displaying a really strange shaped drive wave on the high side drive. So let's see if that's still the case. Power supply still looks good. Turn our scope voltage up so we can see what's going on the output section. Okay, so we have our low side drive on that one there. And let's see our high side drive. I think I might need to actually, yeah. Okay, so this is our high side drive waves, and let's just make sure these all look good. Okay, yep, all looks pretty good to me so far. They all look about the same. That high side drive looks beautiful. That's a very healthy looking high side drive there. And let's check this high side drive over this side. That looks pretty nice as well. Okay, so the amplifier seems to be working just fine. However, I remember that this issue before was intermittent. So you see this high side drive wave? Sometimes I would get a very sloped downward turning off of the high side drive. So I am not convinced that this is perfectly happy. I need to wait because from what I remember, this was an intermittent issue. It only happens sometimes. So I don't trust it. I'm going to keep turning it on and off and seeing if that makes a difference. I'll also try a slightly higher input voltage. So we've got 10.6 volts going in at the moment. So I'm going to increase that to about 12.8. Whoa, something went snap on the board then. What was that? Did you hear that? Something went snap on the board. The fuck? Oh, my rail voltage is still present? Positive rail voltage. Negative rail voltage, yeah, still present. That's weird. Something definitely made a noise. Okay, amplifier still works. So with the higher voltage, it seems okay as well. We're drawing 4.4 amps in operation here. Seems to be okay. I definitely remember an intermittent issue though, so I don't trust it. I don't know why. I don't know why we had an intermittent issue, but I can't remember exactly where it was either. Was it which side it was on? Right, let's see if any of the output FETs were heating up just then. Nope, nope, stone cold, 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 cold. Cold, cold, cold. Cold, 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 cold. So, like, essentially, right now, this appears to be a successful repair. But I know from before that it had an issue with the output section, so I don't trust it. I need it to do the thing again. I need it to do the thing with the drive that it was doing before, so I can find where the issue lies. Because if it doesn't do it, then I can't bloody well find it, can I? That's a beautiful looking low side drive. Very, very healthy shape on the low side drive wave there. Yeah, this is weird. At least the power supply is working now, though. Ah, hang on a minute then, it just drew some current. I just saw it spiked up to about 4 amps just for a moment then. I wasn't probing the right area though, so I didn't get to see what it was doing. I wonder if it's related to knocking the board around. I think maybe it could be something in the power supply section not able to supply enough current to charge the rail caps. I don't think so, no. It seems to be okay. So like right now, this is annoying because it's working fine. I'm just waiting for it to do the thing that it was doing before. You definitely have an issue. Show yourself. Show yourself, stupid issue. Are you related to vibration, perhaps? Should we try bendy the board? I don't like the idea of bending the board when it's turned on, but we might have to. It doesn't seem to do anything. No, bending the board either way doesn't seem to affect it at all. Doesn't make it draw any more or less current. So yeah, interesting. Weird one that. I definitely spotted it doing an issue. So, I mean, I'm probably going to have to just leave this one for tonight because if it's not going to show me the issue, then I can't fix it because I don't know where it is. I can't trace the issue. What I should do though is I should go through all of the drive circuit area and make sure that the resistors are all the correct values and the inductors are all reading the same, all the general basic stuff. Discharge. Yo, Nicholas, how's it going, buddy? I'm not sure if you're watching a super old version of the live stream, but we fixed the power supply already. Like, you might be watching like the delayed version of the live stream, catching up. Oh, and sorry, I missed this previous comment. Nicholas, Bevis, I was watching in bed. The power supply did not soft start. Look at dead time on pin 4 of the 494. Yeah, okay, interesting. Let's see whether the power supply does the soft start now. So I just discharged it, but let's charge it back up again. let's see whether the power supply does the dead time thing now. I'm just going to charge the rail caps first, because when the rail caps aren't charged, it might look like it's doing a dead time thing, but it's not. Okay, amplifier pops into operation. So now I'm going to zoom in on this power supply wave. I'm going to turn her off. Does it come instantly to life, or does it do a dead time thing? No, it does. It does a dead time thing. Now look, it does do the soft start thing. Yeah. So if we probe the gate resistor as well here, if I put it to DC coupling so it doesn't do that weird thing, yeah, it's doing a nice soft start now. So that's cool. It's working properly now. Whew. But yeah, definitely before there was something funky going on with the high side drive, but I can't make it do it now, which is super frustrating because now I can't trace the issue. So that's really frustrating and annoying. This one actually belongs to me, so maybe I should just sell it quick. Sell it quick while it works. No, I'm kidding. I'm not like that. I would not feel happy and comfortable selling this if I knew that there was a potential issue somewhere with it. So yeah, we should just go ahead and check all the normal stuff. All the normal stuff, like all the small green inductors, all the resistors and stuff around that area. The outputs are ones I replaced before. The outputs are... I'm just going to discharge it so I can touch the board again without getting a shock. So I replaced the outputs before. Okay, there we go. Discharged. Outputs are 24N40F. Pretty standard stuff in these amplifiers. I could probably have gotten away with using a 300 volt part, but yeah, fuck it. Yeah, so the output devices in this, yeah, I replaced them and they're all working very happy together. They're all they're all staying dead stone cold. There's no crosstalk. It's very happy. So at the moment the amplifier is in a very happy condition and it seems to work fine. I just know this happened before, yeah. So this is. I've repaired this amplifier before, and so I repaired it and it did this. It worked perfectly fine. It just seems to look great. So I then took it and I put it in the case. I started doing it back up together, and then the issue presented itself back to me again with a slopey wave on one of these high side FETs. So I was like, oh, for fuck's sakes, why are you now showing yourself to me that I'll put you back in the case? Let's try her on 14 volts. Did you do anything with the output drive board? I can't remember. Yeah, I think I replaced the 21844S chips. It's very happy now. It's just weird. It's obviously must be some kind of connection or something. If it's an intermittent fault like that, then it must be like a loose connection somewhere, something that would cause that to happen. So I'm going to try 14.5 volts now on the supply and see whether it makes any difference to how the amplifier works. It's now drawing 4.7 amps. The switching waves look great. Well, we've got 126 volts on the rails, so I probably could have gotten away with 300 volt FETs in this, and some slightly higher current FETs, but what the heck. 24N40 is fine. Yeah, I thought cold solder joint as well, but the issue wasn't getting better or worse when I wiggled the board around or did anything like that. It was staying pretty much the same. It would just kind of appear and disappear at random intervals. Really, really strange. I'm going to turn the voltage back down now. So I've now got only 10 volts going into her. So it seems to work fine at varying different voltages. Yeah, I guess this is another one that I've just got to run endurance tests on. Try and work out what the issue is. It's interesting, there's one FET this side that appears to be slightly hotter than the rest of them. I might load this up with just a fresh bank of new FETs, just purely because I can. So the FETs on this side, after quite a while of operation, then we ran that for a bit on idle. The FETs seem to be. This is a really crappy thing, so FET seems to be about 30 degrees. 28 degrees. So these ones here, yeah, these are about the same, 30 degrees. And let's make sure the inductors are all heating up the same. Yeah, the inductors are all heating up to the same amount as well, which is good. Anything else on the board getting it hot at all, perhaps? Got the voltage regulation section, which always gets hot because that's dropping voltage. That's very normal. Driver board section. Yeah, the driver ICs are just warming up a little bit, which is normal. Yeah, very normal operation. Nothing dodgy here. Ah, Jimmy sends me $2. Thank you, pal. Cheers thank you for the donation there. Is this how you support and donate? Yeah, that's one way you can do it, buddy. Yeah, absolutely. You got the I think there's 3 ways, I guess. There's the super chat on the chat thing, which you can donate. I have no idea. I don't know whether YouTube gives me the whole donation amount or whether it takes a cut from it. I have no idea because I haven't worked that out yet. So people either donating on the live chat or by PayPal or on my Patreon account. So yeah, anything is cool. I don't mind. I massively appreciate any donations and I never expect them, so it's always a nice shock when someone does decide to donate, so thank you. For my LEDs, yeah. Yeah, for my LEDs, yeah. Absolutely. I'm cheap as well, trust me. I'm cheap as well, which is why I decided to resolder my LEDs rather than buying new bulbs. But yeah, okay. Well, I think we're going to leave this one for this evening then, because it seems to work fine. The issue that it was having before is not presenting itself to me, so I can't do any further checks. I'm just going to quickly go ahead and check all these resistors. So these resistors this end all need to be the same value. I think these are like 2.2 ohm or something. So 1.7 on that resistor. This resistor is 1.6, that's fine. 1.6, yep. 1.7, that's fine as well. These inductors should all be about 5 ohm. We've got 1.9 on there because it's in parallel with one this side. That's normal. These ones will probably all be 5 ohm. 2, that's in parallel. 5.8. 2. 5.7, that's normal. Yeah, I'm not really seeing anything else here that's an issue. Got 49, 48 kilo ohm pull downs on this side. .42 there. It could be a pull down resistor because it's slightly different readings. It could be an intermittent pull down resistor. 48, 48, 49, 49, 48. So the pull down value should be around 48, 49. So that's correct. That's correct. That's correct. So what? Hang on a minute. Why was I reading different values a minute ago? I think I might go ahead and just change all the pull down resistors just for good measure. It's when I flip my probes the other way around, I get this other reading. So let's see if that's the case on the other side. 48. So if I flip my probes, interesting. So something is different. So on the side that wasn't giving me the issue, right? If I measure the pull down resistors with the probes one way round, it jumps immediately to 48. If I measure it the other way round, it also jumps immediately to 48, right? On this side that I was getting a couple of small issues with before, if I measure the pull down resistance one way, it jumps to 48. If I then flip my probes around the other way, it, oh for fuck's sakes, it also, this is not consistent. See, this one climbs 44, 45, 46, etc. This one climbs slowly. With my probes one way round, it jumps to 48. With my probes the other way round, it climbs up from 42, which I don't think it does on this side. Oh shit, it does. Okay, well that doesn't help. I thought I'd found the issue then, but maybe not. Maybe that's just what it does. Yeah, it's the same both sides. Damn it! I thought I'd found an anomaly, but I haven't. Yeah, I don't know then. I don't know. Seems fine. I will just have to run it for like many hours and see whether the issue presents itself. So I'll have to have it on in the background, and I'll have to have it on my scope with the drive wave like present at all times, and then I'll just have to keep an eye on the drive wave. And when it goes, if it goes curvy, I'll just have to be like, there you are, quickly probe what's going on, see where the issue is. I'm just going to try and attach a 4 ohm load to the speaker terminals. Now obviously I'm not going to play any audio. Actually no, I'm going to let's apply an 8 ohm load. Just because applying a load can sometimes change how the amplifier's Class D section is acting. So I'm just going to pop a load into the speaker terminals just quickly. See whether it changes how the amplifier is acting. Power it up for one last time, and then we're going to bed. And I'm going to bed. Going to bed. Because believe it or not, it is 2:30 in the morning here in the UK. I am starting to go to bed a lot earlier. I was ending my live streams at like 5 in the morning, but that was a bit too much. Okay, there we go. So we're still drawing the same amount of current even with the load attached, and it's not giving me the issue. It's not giving me the issue, so that's fine. Okay, no worries. Okay, cool. So probably the way to get this to make the issue is if I start screwing it back up in the case, then it will do the issue, because that's Sod's law. That is Sod's law. As soon as you put it back in the case and go to screw it up, and as soon as you clamp all these flipping clips down, then it will present the issue to me, and I've got to unscrew everything again. And then when I get it out the board, the issue will disappear. That is Sod's law. And I know that's probably what's going to happen. Very annoying. But that's life. Can I do anything else before I go to bed? What else can I do? Anything else? Have I got any small things to look at? I repaired this earlier today. I repaired this this Sundown Audio X Series 10. These are, ow fuck, that's sharp. These are pretty nice woofers. And very heavy. Sundown X Series 10, and yeah, this suffered from snapped tinsel leads by the terminal connectors, by the push terminals. That is pretty common, especially with the smaller drivers, because people build far too large boxes for them, and then they just suffer from damage due to over excursion. So this woofer suffered from damage from over excursion and snapped the tinsel leads. So I fitted new ring clamped things to the tinsel leads and soldered it on, and yeah, good as new. Design your switchable variable load circuit. That's not a. For that's it's a pretty simple circuit, but I'll probably do that when I come around to sorting the workshop out. Yeah, I'll have like a board on the wall that I screw the dummy loads to. I have a long thick wire coming down from there. That will then go into like a kind of switch block thing. So yeah, I'll do that all at a later date. What else have we got around here? Bosh. Yeah. So earlier today as well. So I've actually done a shitload of stuff today. I've done a shitload of stuff today. I finished repairing and bench tested 4 B2 Audio 01s. These are fantastic amplifiers. These are fucking amazing amplifiers. B2 Audio are bringing out some beautiful, beautiful amplifiers. This amplifier is rated for 3K, and I benched out of all 4 of them at 1% THD or less than 1% THD, 0.5% THD. I benched 3,950 watts RMS at 14 volts 1 ohm. Amazing amplifiers, really fucking crazy good amplifiers, and they're very efficient as well. Like, it wasn't really straining my power supplies. Usually to bench like a almost 4K, the power supplies would be dropping balls, but I was only seeing like a voltage drop of like 11.7, which isn't that low for like those supplies. When they're really struggling, they're like dropping to like 11.4, 11.5. Does that speaker and cap for gain work for all ohms? Yes, it does. It works for any ohm. Obviously, the lower ohm you connect to your amplifier, the earlier it will clip, because the voltage drop across the rail voltages will be greater. So if you set your gains with a 4 ohm speaker and then you connect up a 1 ohm speaker, you need to reset your gains. Tim Bar, I flexed the board quite a lot a minute ago when I was testing it, and it didn't make any difference whatsoever. So I've got 4 of these in the workshop at the moment, so it's pretty much 4K. So I've got 4, 8, 12, I've got 16K of B2 just sitting here. Amongst everything, I've probably got about fucking 100K, 100 kilowatts worth of amplifiers just chilling, waiting for repair or have been repaired or... Yeah, I think we pretty much exhausted everything for today. I've just realised actually I've got to go and package up some amplifiers. I've got to pack them up for postage, so I should probably go and do that before I go to bed. So yeah, it's been a good old live stream this evening. Never heard of B2? Holy crap! B2 are amazing. Alan Dante? Yeah, Tim Bar. Yeah, I flexed the board many times. It's not a cold solder joint. What are the wattage ratings on your dummy loads? They're non-inductive. Yes, they're non-inductive. Wait, hang on a minute. I don't think there are non-inductive. So the resistance doesn't change when power's driven to them, so it's not a reactive load. But I think they do. They definitely generate an electronic field. Sorry, a magnetic field, right? Because when I had my dummy loads next to my oscilloscope, right, the screen in my oscilloscope is a CRT screen, and so when I dumped power into the resistors, my CRT screen would go whoa 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 whoa. Like this, as if you had a magnet near the screen. So it's obviously generating some magnetic field when you dump power through them. So to do that, I guess it's going to be inductive. But they are 1,000 watt continuous each. So I've got four ohm loads, each at 1,000 watt continuous, and the pulsed dump rating on them is like 3 or 4K. So I can dump flipping like 15K or more into these four. Modbox confused. Yes, plug the small cap and the speaker in whilst the sub is connected. If you don't do it while the sub is connected, then you set a clipping point that is far too high. So you need to set your clip point using the small little device that I recommended with your sub plugged in. All right, cool. I think that's it for today. We had a very successful day. Repaired B201s. Finished repairing and bench tested the MTX Road Thunder. And got further with our Rockford Fosgate BD1500. Bench tested the US amps AX 3200DE. Didn't seem to have an issue. What else did we do? I think that was it. And then we looked at this SPL Dynamics and we fixed the power supply drive issue. So yeah, pretty successful day of live streaming and repairing, so thank you very much for tuning in, and I hope that you had a great evening of watching and it was somewhat entertaining to you, and I shall catch you on the next stream.